Hello, I'm Jack. Welcome to my YouTube channel, Practical Programming with Dr. Su. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In this video, we will use WebGPU version 0.1.13. Currently, this is the latest version. In the last video, we discussed how to create a 3D clean bottle surface chart with both color-mapped surface and a wireframe on the surface. In this video, I will use the same framework to create a parametric 3D Wellenkugel surface chart. Here we will use the Git tool to clone the source code used in the last video. Here is the download link at Github Repository. From this link, you can download the source code used in the last video. Now, let's start Visual Studio Code directly from Windows Start menu. Visual Studio Code. Here is the Visual Studio interface. Now, let's start a new terminal window and cd into code folder. In this folder, we make a new subfolder called GPU 48 and cd into it, GPU. We can then clone the source code used in the last video with the command git clone WebGPU 47. Here we need to, after this comment, have a space and a period. This will place all our source code in the current folder. So run this command. You can see all the source code is placed in the current folder. Now open this folder from Visual Studio Code. Open folder is code GPU 48. Here contains the source code used in the last video. Now open a new terminal window and run the command npm install to restore all the npm packages used in this example. Okay, finished. Now all the installed packages are stored in the node modules folder. In this video, we want to create a parametric 3D Wellenkugel surface chart. The Wellenkugel surface can be defined using a set of parametric equations as shown here. You can see x equals to u cosine and cosine u sine v, y equals to u sine cosine u, z equal to u cosine v. Here u and v are parameters. Previously, we have implemented the Wellenkugel function in the mathfunc.ts file. You can open this mathfunc.ts file. You can check here Wellenkugel math function. You can see here we can reuse this function in our current example. Next, we need to make changes to the index.html file from dist folder. Open the index.html file. First, we need to change here the title 47 to 48 because this is 48th video. Then we need to change the H1 title from clean bottle to Wellenkugel surface chart. The parameters used in this example is the same as those used in the previous example, so we don't need to make any change here. You can see here this drop-down menu lets you select different square images for our wireframe. You can see here we have 10 different square images to choose from. This is a drop-down selection for the color map that contains 11 color map names defined in the color map data.ts file. Now we can save this file. Next, we need to make some modifications to the main.ts file from src folder. Open main.ts file. Since most code for render pipeline and render path have been already included in the chart.ts file, so the main.ts file here becomes very simple. Here we first introduce the create chart with the texture from chart.ts file. Then from surface data.ts file, we introduce parametric surface data methods. Then from math func.ts file, we introduce or we need to replace clean bottle by the Wellenkugel function. Next, we create a chart function with input arguments texture file that lets you select different square image for creating the wireframe. Here, the color map name lets you specify color maps for our 3D surface. Inside this create chart function, we call the parametric surface data function. Here we need to change the math function to Wellenkugel. So here we need to make some change to this code. You can see we change the math function to Wellenkugel. Also we change the value range. Here 0 to 5 is for V range. Originally, the V can take a value from 0 to 2 pi, but here we set it to 0 to 5 because we want to see the inside of this Wellenkugel surface. This parametric surface data can generate the vertex, normal, color map, and UV data. We can then call the create chart with texture here to create our Wellenkugel surface chart with both color maps and wireframe. The rest of the code is the same as I used in the previous example. Here we define the default square image using the white square file. The default color map name is set to the jet here. We then call the create chart function to create a 3D Wellenkugel surface chart with default color map and wireframe. This part of the code allows the user to recreate the surface chart with different color map and wireframe by selecting them from the two drop-down menus defined in the index.html file. Now we finish the modification to the main.ts file, so we can save this file. Up to now, we have finished all the programming. We can then run the following command on the terminal window. npm run prod to bound our TypeScript code in production mode. Okay, the bound file is created successfully. Now we can click the Go Live link to open Chrome Canary to view our Wellenkugel surface. Click this link. Here is our Wellenkugel surface chart with the default jet color map and white wireframe displayed on this page. You can see our 3D surface chart looks very nice and pretty. You can also look inside the structure of this surface. You can see here. Here we can change the color maps by selecting different color map name. For example, Q, HSV, Summer, and I go back to default jet. We can also change the wireframe color. For example, red, green, and blue, and black, and go back to white. You can see the same issue for our wireframe color occurs when we select a square image with different color other than white. The wireframe color does not really look like the pure color except for the white. Previously, we have explained the reason for this issue using our Cedar code. Even though we cannot get a wireframe with pure color except for white, we still get very nice looking 3D surface chart with our square textures. Now we have completed this example. In next few videos, we will discuss how to create multiple objects in a single canvas surface. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a Github Repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.